Good evening, Robin was joins in. Okay, so it's 8:05. I guess we can begin now. Once again, good evening, everyone. My name is Dan Ladi. Robinson, please, I need permission to record. Okay. Okay, so let's jump straight in. This is okay. This week we're going to be looking at data visualization using a previously provided data set, the comedy data set. So basically presentations that you can deliver to non-R users. So it allows you to prepare like documents in different formats and share to people. So I'll prepare it in the shareable format so we can just walk through it together. I hope everyone can see the R Markdown. Yeah. So I hope everyone can see it. The first thing is the title and the names of the authors and dates. So these are like these options can be preset. For example, let me just, if you in R Markdown you can prepare the title, you can prepare the name of the author and the dates. Now this date can be set to either auto update or to be a fixed date depending on what your needs are. So we'll not go too deep into R Markdown, but it's quite useful for preparing reports. Now this is a HTML file. You can prepare an R Markdown file into PDF, HTML, PowerPoint, or Word. So straight in, we'll just look at the data. So first, we loaded the necessary packages. First, we loaded Tidyverse, which is a package for data manipulation and wrangling and all sorts. It allows you tidy data, visualize data, do basically just get the data in the form you need it to be and visualize it. So we also loaded the Royal package, which allows you reading files. But I use the tidyverse package to read in the required file. Now to read the data, you use the read_CSV command, and then you supply the name and the location of the data set you want to read in, and you assign that to a variable. So I assigned it to the variable called data. So after doing that, we now have that data set in R. So let me just show what it looks like. So first things first, when you get the data, we receive the data in a CSV format, and after receiving the CSV format of the data, you want to be able to do what you need to do with it in R. So from the CSV, you read it into R, and you create a variable that you can work with. So after we read the data and converted that to a table, and calling on the variable, that's just running this data, which is just the name of the variable. Because it's a table, it gives you a sort of overview of the data. We have a table with this number of rows and this number of columns, 4 columns and 612,000 rows. And these are the column names: viewer ID, joke identifier, response ID, rating. So the first thing you need to do is, after getting this sort of overview of the data, you can also use the glimpse command to get an overview, present it in a sort of more compact way, in case you have like numerous columns. But anyway, we only have 4 columns in this data set, so this here is sufficient. So after calling in the data and having a look, you sort of get an idea of what you want to do, how you want to clean up the data. There's a concept known as tidy data, where each row is a set, is actually the responses of 612,000 ratings for comedy jokes. So comedians would tell a joke and someone would listen to the joke and rate it on a scale. I'm not sure of the exact bounds of the scale, but basically they would rate the jokes on a scale, and then there would be the identifier for the viewer, the name of the comedian, the show where he performed, and the edition of that particular show. So there's a popular show in Nigeria called, a comedy show called Night of a Thousand Laughs. So let's say it was held in Enugu, which is a state in Nigeria, and this was the first edition. That's what this represents. And then there was a response ID, which sort of merges the viewer ID and the comedian and the show and all that together. And then the rating that was given to that performance. So after having a look at the data like this, you sort of have an idea of what you want to do with it next. And that's what we are moving to now. So like I said before, there's a concept called tidy data, where it allows you, it makes data easier to work with. So basically what you do is, each row is a separate observation. And if you notice in this data set, that is the case. Each row here is a separate review by a reviewer. It also says that each column is a separate variable. Now this data set doesn't exactly follow that, because in this joke identifier column, we have both the variable for the name of the comedian, the location where the show was performed, and the edition of the show. So that doesn't really tally with our tidy concept. So what we're going to have to do first is to tidy up the data. And to do that, we'll take a series of steps using the packages within tidyverse to help. So having done that, we first of all view the names of the columns, which we've seen before. And then we want to now what we want to do next is we want to rename want to sort of reselect the columns. Now we've decided that we don't need this response ID column, because it's a combination of columns we already have. This is simply this by itself redundant, so we can drop it. So to drop it, select Usually in square brackets, you can specify the rows and the columns you're interested in. Now we've left out the row specification, meaning we want all the rows and we've kept the column specification. But if you notice, we left out one of the columns, response ID. So what this line does, it drops the response ID column from data, or it selects everything but the response ID column and reassigns that. Now we have 1, 2, 3 left. So after doing that, we want to extract out these names, the state and the show name. So to do that, there are multiple ways, but look. So to do that, what we use is the stringer package. Stringer is a package within Tidyverse that is useful for manipulating strings. Strings are basically any form of textual data. So if you notice, we have the type of data here: character, 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 character. So these are all strings. This is double, which represents a number. There are also other formats, but what we have currently is character and double. So for those columns that we want to extract out, we use the str_extract. Now all the functions in stringer, they start with str and easier. So first of all, we want to extract the show from the so this joke identifier consists of the name of the comedian and the show. So first we'll extract the show from the name of the comedian, and we use this str_ extract. The first thing you supply is the pattern. Now in R there's something called regular expressions. Usually strings have a fixed format. For example, you may want to extract the last digit in a string, and there's a sort of regular expression. Now, to go into details, the regular expressions will take too long, but this regular expression simply extracts the location and shows. To shows, we extract from joke identifier the pattern, everything that matches this regular expression. And what that does is it extracts the location and the edition. How we've identified that is we've simply said coming from the end. For example, if you look here, coming from the end of every string, we have first a number, a space, and then a set of characters and a space. So use the regular expression to extract this pattern from every single entry. So we take a number, a space, the location, and then another space, and we create a new column called shows, which we assign that to. So after doing that, we now have a column called shows that contains the location and the state and the edition. So we still need to extract from this again the the specific location and the specific edition. So we use two more string extract calls. What we do is we extract from shows the pattern that matches the state. So what we're basically saying is take the first thing you see here before a space and extract it and name that location. So it will go through every single row in this data set and do that for us. Then we want to extract the version. So we tell it to come from behind and take every number and extract that as well. So we do that. And then now the thing about string extract is it doesn't modify the origin from joke identifier we've extracted from version or from shows, sorry. We've not really changed those columns. So we need to extract again a sort of we need to find a way to remove the the comedian name from this joke identifier separately. So what we do is we remove, shows now is the location and the edition. while joke identifier is the comedian, location, and edition. So we remove from joke identifier everything that matches shoes. So for example, from this who's my Robinson phone of the person that is on. Thank you. Yes, so as I was saying, so from the first, let's use the first row as an example. We are creating a comedian column, and from to create this column, what we are doing is we are removing shows from joke identifier. So from this screen, let's claim the drunk. I will do that for create a new column called comedian. So after doing that, we no longer need the joke identifier and the shows column since we've created comedian location version from it. So we'll drop those. So to drop those, we once again specify the columns we need and we assign those columns to data. So there are other ways of doing this. You could use pipes, but this way is a bit more easy to understand. So after doing this, we now have a new data set that is simply joke identifier without, sorry, we convert all the characters to categorical data in R. So we want to convert this factor characters to factors. So after doing that, we want to sort of get a feel of what our data looks like now. So what this call does is we supply the name of the column, giving out this data minus all the last column in data. Ignore the last column. All the other character columns, we just convert them. We just want to look at their levels. So the number of levels they have, basically. So this tells us there were 40,862 viewers, which is a lot. There were 14 comedians, 10 locations, and 5 versions. Moving on, we want to look at the names of each of these comedians, locations, and versions. So once again, we leave out the viewers and the rating, and then we simply tell R to tell us the levels for each of the remaining columns. The map function simply goes over each column and applies the command you've given. So first we look at the comedians. We have Clean the Drunk, Alibaba, Aso, Basket Mouth, AY Bovi, Apororo, I Go Die. These are all Nigerian comedians. Most of them quite popular. Then next we look at the locations: Enugu, PH, Lagos, Warri, Rock, Abuja, Owerri, Benin, and then the version. Now there's a small problem with what we've done so far. Because of the way we described our regular expressions, there's a location that had 2 words, but our regular expression only extracted the first one. Remember I said we would take the last number and the last word. So there's a location called Aso Rock. Our regular expression only took out the rock and left out the Aso. So we need to sort of manually correct this. So to do that, we use the mutate function. We pipe data to the mutate function. We tell it, okay, modify location. Anywhere you see a location called rock, replace it with Abuja and convert it back to a factor. Anywhere you see a comedian called Alibaba Aso, correct that to Alibaba and replace that with a factor. So that's like the whole idea of viewing the levels in our data. It sort of helps us easily identify if there's a problem we need to correct. If all our commands is fine, we're done with our data wrangling. Our data is in a state where we can now work with it and carry out our visualizations. So We move on from that to visualizing data. The package for visualizing data in R is called ggplot. Well, not the package, but one of the. It's sort of the most popular anyway. It's called ggplot2, and it allows you build graphics in a consistent and easy to remember manner. Well, not really easy to remember, but fairly consistent so that you sort of have an idea of how to achieve what you want. So the first thing you do is to call the function, which is ggplot, to supply the data you're going to be working with, which we have called data. Then you call, there's a function called AES, which stands for aesthetic mapping, and you sort of provide an x-axis and a y-axis. So every graph has an x-axis, which is usually the lower border, and a y-axis, which is usually the left or right border, depending on how you look at it. So after doing that, you in using ggplot, there are things called geomes. Geomes help you build the specific type of visualization you want. So there are many visualizations, there are histograms, but of data you want to visualize, you can decide what kind of visualization you're going to use. So this time we've chosen to visualize a histogram because we are looking at the distribution of the ratings in our data. On the x-axis, we have each of the ratings. There are 5, extending from -5 to +5. So I said earlier that I wasn't sure of the bounds for the ratings. It's actually from -5 to +5. A continuous spectrum. And then we have with -5 being the worst rating and +5 being the best rating. And then we have the count for how the data was rated, basically. So we then call geom histogram, supply a bin width. Bin width just tells us how wide we want the bars to be. And sort of, depending on how you vary the bin width, it can expose patterns in the data. And fill is simply the color. So you use fill to tell it what to color the bars. So bars are light blue. So these are other sort of styling guides. We have guides. Now we go on to that in a bar chart. This is a bar chart. The system for ggplot, like I said before, it's very similar. Once again, we call ggplot. We provided the data set that we want to work with. We gave it the x and the y axis. And then this time, instead of using geom underscore histogram, we use geom underscore call, which is there's geom underscore call. You have to apply both the x and y axis. That's for what fills the y axis, which is the colors, still blue for text, and we provided the label of count. So we supplied our previously counted groups. so gem underscore text, and um, size is just what size we want the text to be. So what this has created for us is basically a plot of each comedian and the number of shows they have performed at. So immediately you see that I Go Die performed at 13 different shows, Akuro, Bovi, and Alibaba being the most, and then Basketball, Clean the Drunk, and then Sakashi, or AY, and Funny Bone being the list with just 4 performances. Now, the importance of visualization sort of comes up when you observe that we've been able to convert our initial data set of 612,702 rows to instant information. Anyone who sees this, starting from here, is able to easily identify certain things about our data. For example, this is our average. This is sort of the distribution of our ratings. These were the most popular comedians based on the number of shows they performed. We also want to look at the ratings for each of the shows. So we'll go on to visualize those as well. Um, okay, so to do that, what we tried to do was, first of all, we want to visualize what was the rating on average for the shows in each state. So usually when you receive data, you have questions that you want to answer, and you use your skill set to query the data and get answers for those questions. Now, for this plot, we calculated the average rating for each location. That now, if you notice, immediately you can tell that were highly rated, while shows in Enugu were like the least rated. They had negative ratings of the comedians rated. So Clean Drunk has, by and large, the largest repertoire. He has more than twice what anyone else has. So AY. And this is despite the fact that Clean the Drunk wasn't the most frequently performing comedian. His own shows were seemingly quite long. While Okay Bakassi just has 12, Funny Bone has 13. So maybe these were like cameo appearances, just very brief, very short appearances. So once again, this answered the question of how many performances had each comedian done. Moving on. Okay, so moving on, above, this is just sort of a quantitative count. Doesn't really tell us how good the shows were. Okay, so we then moved on to look at which locations had the most shows. To do that, we grouped by location and then counted that to gem underscore call to create a bar chart of locations. Okay, I forgot to point out, there's also a command in ggplot called flip. What that does is usually when you have the x horizontal, it gives space. So sometimes you have the text clashing when they are too close together on the x. So you can flip. What this does is we want to see the count of each of the locations and how many shows they each had. So immediately you see that Lagos had the most, Benin, Uyo, Ibadan, and Owerri. And this is sort of in line with what we would expect. Lagos, like the biggest states, population-wise in Nigeria, the most density and the first mostly in Nigeria, Lagos, Abuja, Port Harcourt, and then Warri. Visualizations we've done so far, we've been able to answer some questions. Which locations were the most used, and what was the distribution of ratings for our entire data set? So, we also remember there were different versions. So we had version 1 to version 5, and want to see the number of versions for each show. So what we did was we grouped by version, counted that. So it's likely that not many people went from version 1 to version 5, and sort of our data follows that pattern. Now, we also want to look at, okay, how many times did comedians perform in each version? How many times were they rated in each version? So each comedian would have performances, and would they perform from version 1 to 5, or would they just perform in version 1? Questions you throw around and allow the data. We now we are using a different geom. Instead of geom underscore call, we're using geom underscore bar. And if you notice, we're only supplying the x-axis, which is comedians, and then we're supplying a field, which is versions. So what this field equals version does is, instead of coloring the data the same, it colors the data based on version. So instead of everything being red or everything being blue or yellow, we simply say, okay, for version 1, let it be red. For version 2, R takes care of this automatically. So all you do is just say field equal version, and it will give each version in our data set a unique color. And usually this works with categorical variables rather than continuous. And it just allows called geom underscore bar with him. We use now facet underscore grid. When we ran field equals to version, it sort of created multiple bars. Now facet underscore grid allows you separate out these bars. If you don't do this, it will be one graph with all the bars sort of overlaying each other, which may not be as informative as we want. So we use facet underscore grid to specify what rows we want. So we said vars, rows equals vars version. So what this does is it creates a separate row, sort of like stacking 5 different charts on top of each other. And immediately we can see that, okay, Clean the Drunk performed at the first 3 shows, but he didn't perform at any version 4s or 5s. Alibaba performed at all 5 versions. Basketball performed at 4. Bovi also performed at all 5. And there are multiple interpretations we can give this data. although we would have to look further down to see. So this above graph shows that most of the time viewers were rating comedians in version 1. We already knew that from this, based on the viewer ratings in version 5. As you can see, there are only 2 or thereabouts, while version 1 has ratings for almost everyone. So the conclusion is maybe people did not watch the later versions, maybe they focused more on the earlier versions. We also did the same thing with locations. We saw that, okay, what locations had multiple versions. So this chart is very similar. We just changed the x-axis from comedians to locations, and off the chart we can see that Port Harcourt, Lagos, and Port Harcourt, Lagos, and Abuja had 5 versions. Warri and others had at least 3. Some had 2. Some even had just 1. Owerri had just 1 version. You notice that some states had Port Harcourt at the top, and in this we can see that Lagos, Abuja, Port Harcourt were locations that had at least 5 editions. So we expect them to have more. Warri 4, and then the others, Owerri was the least, and as we can see, there was only 1 show held in Owerri version 2. So that could also say maybe the location popular certain locations with the quality of the ratings. Now, this box plots I will explain. We have Funny Bone, which is one of the comedians. Now, the box plot is such that we have the box and then the tail. Now, the box represents from one end of the box to the other, represents something known as the interquartile range. The middle, so it's sort of like the middle of the data set, is sort of average, or sorry, a sort of 50% point. So half, it's like a halfway mark and gives like an idea of the general structure of the data set. So from this, we can see that Clean the Drunk had the lowest of the ratings. Despite having the most shows, he had the lowest rating, a sort of even, and his rating of artists had positive ratings, or median rating, sorry, of all the comedians. Now, beyond the interquartile range and the median, these tails also tell us the sort of distribution of the data. So the highest positive rating but Funny Bone received was less than 5. So no one rated him a 5, but he received some low ratings. So despite all the other comedians having ratings in the extremes, at least we can see that most of them had on average positive ratings, with the exception of Okebakasi. So we can then move on to look at the mean of the ratings for each of the comedians rating. How we do that is after grouping, we calculate the mean of the ratings in each group and round that to a certain figure. And then we see that Clean the Drunk had the lowest mean. Alibaba had a positive rating. Every other person had a positive rating except Clean the Drunk, with Gordon's having the highest. To make it sort of, so what we do is we create another bar chart where we have the comedians on the the flipped x-axis, which is now the y-axis, and their ratings on the x-axis. So immediately we see that Gordon's had the highest mean rating with 1.74. AY next, Helen Paul, then Aporo, Alibaba, Igodai, Sheila, Bovi, Basketmouth, and OK Bakase had the lowest rating with minus 0.33. So we can say that on average, our viewers were unimpressed with Clean the Drunk and were very impressed with Gordon's jokes. And there's a spectrum of comedians between that. And this is particularly surprising because Clean the Drunk had the most jokes reviewed. So we want to sort of dig deeper to sort of uncover any other hidden secrets in our data. So we once again call some box plots on the states. So this time around, we're looking at the average rating for the states, or the median rating, sorry, for the states. We see that 2 states had negative ratings, Enugu and Owerri. On average, viewers did not enjoy shows in these locations. While jokes from Benin had the highest rating, and then there was a spectrum of views in between. To color our data set like this, we simply use field is equal to location. So each location was given a different color. And then we sort of can see how the shows were rated in each state. Now, we also want to look at the versions. Now, were some versions more better received than others? And from our plots here, we can see that the median review for all the versions was positive. So version 1, 2, 3, 4, 5, on average, people enjoyed them. But there wasn't much difference between versions. Although version 5 seems to have the highest median, it's not significantly different enough from any of the other versions for us to hone in on that. So that gives us an idea of any other significant differences in the data. Now we also may want to look at how different locations were rated by version. So we have each location, and then we have what this plot is showing is every location for every version. So in version 1, what locations were highly rated, what locations were poorly rated. Same for version 2, 3, 4, and 5. So from this above, we see that every location was rated in the first version because every location had an event in at least version 1. And then as we progress in versions, some locations were dropped, maybe because of attendance or the like, and only the 3 largest locations remained by the time we had gotten to version 5. So even in the manner the versions were dropped, it seems like they were dropped based on rating or based on population, because Owerri was dropped first in version 3. And then by version 4, we had also dropped Enugu, Benin, and Uyo, leaving Ibadan, which is a big town as well. But by version 5, we had only kept the 3 largest towns. So this sort of summarizes the rest of our data. And then we now look at how each of the comedians were rated by version and location. Now this plot is actually a bit or quite difficult to read effectively. But basically what this does is we're saying, okay, for each comedian, they performed at multiple locations in multiple versions. So each color represents a different location, and each row here represents a different version. So for example, Clean the Drunk, he performed in version 1, he performed at 4 locations. In version 2, he performed at 4 locations again. By version 3, he only had 2 performances, and he didn't perform at all in versions 4 or 5. The same holds for many others, although they seem to be more consistent. Alibaba performed 3 locations, 2 locations, 2 locations. And from Alibaba's distribution, it sort of seems like he performed at only the big shows, performing at Port Harcourt, Lagos, and Abuja, based on the color of our legends here. And then by the fourth and fifth version, artists, sorry, shows, but from this overall, we can say that no one performed in every show. So there were distributions between what shows they performed at, what versions they performed at. Um, that sort of gives an end to our summary on visualization. Basically, this whole exercise was just to have a look at the data. If everyone carries out the same exercise, the results will be different for everyone, and there's no particularly right or wrong way. It's just how you're able to pass the information you want to pass in an acceptable way, without sort of giving a skewed view of the data in a sort of unbiased way. So that brings us to the end of this presentation. I'd like to thank Robinson. This entire presentation was mostly his work, although I contributed a bit. And I'd like to say that, once again, the easiest way to learn is to actually do. So if you were to pick up any data set and try to visualize, run into problems, find out solutions on Google or by asking others, it goes a long way in helping you remember most of what has been discussed. So if there are any questions, I'll answer questions now. We'll give a few minutes for any questions to come up. If there aren't, we'll end the class. Thank you all. So I'll be waiting for a few minutes to answer any questions that may come up. Okay, I also wanted to suggest for anyone interested in practicing out these things, trying out things, and you need a sort of data set to work with, there's a sort of, they basically supply data sets and ask everyone to sort of just try out their hands on visualizing the data. So if you go to Google and just type in Tidy Tuesday, you'll get a link to the GitHub and you can download the data and work with it as you like. I'll post the link in our chat window, so anyone interested can just have a look. Thank you all very much for coming. I hope we all learned something. And I guess we'll meet again next week. Have a good day.